Today's lesson is on the law of sines and the law of cosines. So remember the other three ways we have learned to solve triangles? We had the Pythagorean theorem, we had special triangles, and we had trigonometric ratios. Now, all three of these methods could only be used to solve right triangles. What we learned today is there is two ways actually to solve triangles that are not right triangles. And those two ways are called the law of sines and the law of cosines. Let's begin with the law of sines. In the law of sines, we can use it to find missing parts of triangles that are not right triangles. So look at this figure here. That is not a right triangle, but we're telling you anyway, there is a relationship between the angles and the sides of this triangle. So if we had this triangle here, we say that the side across from angle A is here. The side across from angle B is here. And the side across from angle C is here. And we say that the sine of angle A to side A is equal to the ratio of the sine of angle B to side B, which is also equal to the sine of angle C over the side C. So we're usually given two angles, any combination of these two angles, and we can use that to solve the triangle. So two very important things. In this notation, the letters A, B, and C, when written uppercase, are the names of the angles. So if we have the figure here, we label the angles this way. Then we say that the sides across from those angles are the lowercase versions. So uppercase letters are angles. Remember, uppercase angles and lowercase letters are sides. So when do we use the law of sines? When we're given two angles. We're going to come back and talk about the law of cosines later. So let's keep working with the law of sines here. There are three steps we use to solve a law of sines problem. Step one, we always draw this triangle here. It's going to be the same triangle every single time, so you better get used to drawing it. However, sometimes the problem might say triangle XYZ or triangle ABC. Whatever they name the triangle, the uppercase letters are the vertices of the triangle. Just know that. And then the lowercase version of that letter becomes the sides. So we draw this triangle every time. Then step two, the problem is going to give us some information. We put that information into the triangle. The problem is going to say, the measure of angle A, the measure of angle B, or the measure of angle C, or it's going to tell you side A equals, side B equals, side C equals. You need to know when you're reading the problem to say in your head, this means angle, this means side. Then you put that information onto the figure. Then you need to determine whether you're going to use the law of sines or the law of cosines. In all of the problems that I'm about to show you, we're going to use the law of sines, and then we will substitute. So let's try the first one here. It says, find each measure using the given measures of triangle X, Y, Z. Round angle measures to the nearest degree, and side measures to the nearest tenth. Okay, so here they give us triangle XYZ, and these are all uppercase letters, so we know they're talking about angles X, Y, Z. There's a relationship between the sides and the angles. Across from angle X, we have side lowercase x. Across from angle Z, we have side lowercase z. Across from angle Y, we have side lowercase y. So this is our first step every single time we draw this triangle. Then we look at the problem and look at the information it gives us. So we're doing number 1 right now. It says x equals 3, so I'm going to put that in the figure. X equals 3. They say lowercase x, so I know they're talking about a side. They say angle x equals 37. I put 37 degrees here. And angle y equals 68 degrees. I put that here. I need to find side y. So I have done my second step here, put the info in the figure. And now step 3, we choose whether we want to do law of sines or law of cosines. We're going to use law of sines, so now we substitute. We get the sine of angle x is to side x as the sine of 68 degrees is to side y. The sine of angle y is to side y. And now we substitute our numbers from the triangle in. We get the sine of 37 over 3 equals the sine of 68 over side y. Now I cross multiply, and I get So I get 3 times the sine of 68 degrees equals y times the sine of 37 degrees. I divide both sides by the sine of 37. Sorry, I ran out of room. And we get y equals, just plug this into your calculator. 4.6. Let's do the second problem here. Remember, we always start by drawing the triangle. So they say triangle XYZ. I know those are my angles. I put the sides across. And now I look at the problem. The problem says, if side y equals 12.1, the measure of angle x is 57 degrees, and the measure of angle z is 72 degrees, we need to find side x. Okay, so here they give me 2 angles, so I know I'm going to use the law of sines, but unfortunately, my angles do not match up with sides. I'm supposed to be finding side x, but side z doesn't match up to angle z, and I don't know what angle y is. So we can either do law of sines twice in order to find the measure of angle y, or we can just subtract. Subtracting is much easier. We know that 57 plus 72 plus angle y equals 180. So I solve for angle y, and I get angle y equals 51 degrees. So I'm going to put that in the figure. Now I have a side across from angle y. And now I just set up my formula. I get the sine of 57. Sorry, that looks like a 3. The sine of 57 over side x equals the sine of 51 over 12.1. I cross multiply. I get 12.1 times the sine of 57 equals x times the sine of 51. Divide both sides by the sine of 51. And I put this in my calculator. What do I get? X equals 13.1. Let's try these last two. Step 3, I'm going to move a little quicker now. We have triangle x, y, z. I put my sides across. Now I look at the problem. It says side y equals 7, side z equals 11. Angle z is 37 degrees, and we're trying to find angle y. So I find my pairs I'm going to use for the ratio, and I get the sine of 37 degrees is to 11, as the sine of angle y is to 7. Cross multiply, I get 11 sine y equals 7 times the sine of 37. I want to get the sine of y by itself, so I divide both sides by 11. I get the sine of y equals 0.8 something, something, something. So now, remember, whenever you're looking for the angle here, you don't have the angle, you have to do sine to the negative 1. Sorry, that's not very neat. Okay, you have to do sine to the negative 1 of this number here. And you get 55 degrees for the measure of angle y. And let's do the fourth one here. We put the information in to the triangle. The side across from x is x, the side across from y is y, the side across from z is z. And now we look at the picture, we look at the information. It says if side y equals 17, side z equals 14, the measure of, hold on, let's move this over. Side z equals 14. The measure of angle y is 92 degrees. We need to find the measure of angle z. Okay, so we find our pairs and we set up our ratio. We do the sine of angle z is in front of the side that measures 14 equals the sine of 92 over the side that measures 17. Now we cross multiply. I get 14 times the sine of 92 equals 17 times the sine of z. Divide by 17. Divide by 17. I put this into my calculator. I get the sine of z equals 0.823. Whenever I don't have the angle here, I have to do sine to the negative 1 of this value here, and I get 55 degrees as the measure of angle z. So this one here, I had mixed up the two decimals. This one I changed the answer, but this one here is 55 degrees. Okay? So now let's talk about the law of cosines. I'm going to go back to our first page. So the law of cosines is when we have the lengths of the sides of a triangle and we only know one angle. So if we have one angle in between two known sides. So let's say I know B equals 5 and A equals 7. If I'm looking for this angle here, I use the law of cosines. So I use the law of cosines when I have two sides and I'm given one angle. Okay? So let's look at this one here. It says, find each measure using the given measures from triangle ABC. Okay, so notice we use the exact same figure that we used in law of sines. So we learn how to draw this figure because you're going to use it every single time. So the law of cosines states that a squared equals b squared plus c squared minus 2bc cosine of a. So the reason why we don't go too far into this one is because it's just simple substitution into an equation. So they tell us here that b is 14, c is 12, and the measure of angle A is 62. So we need to find side A. So look, they give us a side here, they give us a side here, and an angle in between. If we have one side and two angles, we know, if we have, two sides and one angle, we know we're going to use law of cosines. So let's plug these values into the equation down here. I have a squared, which is the thing I'm looking for, equals b squared is 14 squared, plus c squared, which is 12 squared, minus 2 times b is 14, c is 12, and the cosine of angle A is the cosine of 62. Now I just plug this into my calculator. Let's see, I get 14 squared plus 12 squared gives me 340 here, minus 2 times 14 is 28 times 12 gives me 336 times the cosine of 62. So let's do 336 times the cosine of 62. I get 157.74. I'm going to subtract that from 390, and I'm going to get 232.25. So I get a squared equals 232.25. Square root both sides. I get a equals 15.2. And that's law of cosines.